Now we are going to solve the problem number 7.10, which is given in page number 72 in wave optics. This problem is based on diffraction of light in single slit. Look at the diagram here. Only one slit is there through which the light is passing through. We know very well that when light passes through the slit, the light gets diffracted. The wavelength of the light is given how much? By 5000 Armstrong unit is given. The width of the slit is A. Width of the slit is how much? A. You are asked to find out the width of the slit. Here two light rays, they bend and they are interfering with each other and they are forming the diffraction pattern. In diffraction pattern, the central portion of the fringe, that one will appear in the form of a central maximum. Central maximum means a bright, broad fringe is created at the center. The name of the fringe is called central maximum. That central maximum that is extending up to 2 minimum. This is called first minimum. This is also called as first minimum. So the central maximum, it spread up to in between two first minimum. Here one first minimum is there, on the other side also one first minimum is there. In between these two first minimum, that central maximum is appearing. Are you clear? Now you are asked to find out the value of A, and then the angular spread is given. The angular spread means what you have to do, from the midpoint of the slit you have to draw a straight line. Therefrom you have to extend the line up to the first minimum. In between these two, in between this reference line and the another line, diffracted ray line, in between these two, that angle must be measured. That is called angular spread. That is otherwise called as theta. Are you clear? Theta is called as angular spread. Okay. So you know all the factors one by one. To solve the problem, we should know the equation for diffraction minimum. Are you clear? The condition for equation for diffraction for minimum. Are you clear? So diffraction for minimum is, what is the formula? Very basic formula is A sin theta is equal to n lambda is the condition for the minimum. Are you clear? So in the case of single slit, the diffraction for minimum can be obtained by A sin theta is equal to n lambda. Here A is nothing but the width of the slit and theta is nothing but angular spread of the rays. Is it clear? Which causes the first minimum. Since the central maxima is confined within the two first minimum, is it clear? We are able to take the condition for first minimum. Here what is n? N is nothing but that first minimum now, since the first dark band is taken, n must be taken as 1. Are you clear? This is the condition for minimum. Therefore, instead of n, is it clear? 1 must be substituted. Are you clear? Now we have to interchange the formula. A is equal to n lambda divided by sin theta can be written. Here angular spread is given and we know very well that the order of the minimum is 1. First minimum no, therefore n instead of n 1 must be substituted. So here substitute here A is equal to 1 into wavelength of the light which falls on the single slit is how much? 5000 Armstrong. So 5000 into 10 to the power of minus 10 must be substituted, divided by sin 30 must be written. Sin 30 must be written. We know the value of sin 30, it is nothing but half. Therefore, A is equal to 5000 into 10 to the power of minus 10 whole divided by 0.5 can be written. 0.5 can be written. Okay. Now, after displacing the decimal point, what you will get? This one can be written as 5 into 10 to the power of 3 into 10 to the power of minus 10 This one can be written as 10 to the power of, clear, this 0.5 can be written as 5 into 10 to the power of minus 1. If it is brought up, that one becomes plus 1. In the denominator 5 is there. This 5 and 5 can be cancelled. Are you clear? So finally you will be getting the answer as 10 to the power of minus 7. This one you will get minus 7, and then you will get 1 minus 7 minus 6 you will get. Are you clear? So 10 to the power of minus 6 can be written. 10 to the power of minus 6 meter can be written. This one could be written in terms of millimeter also. So finally you will be getting 0.001 millimeter. So that is the final answer. So the answer could be written in terms of meter as well as in terms of millimeter. The most important thing is, two things you have to understand. One is, what is angular spread? That is the angle subtended between the straight line which is drawn from the mid of the slit up to the screen. That is the reference line, and then this is the ray which connects the center part of the slit up to the first minimum. So there one angle is subtended, no, that is called angular spread. Are you clear? So the another one is where the central maxima is created. The central maxima is created in between the two first minimum on either side. By using these two reference first minima alone, this portion is taken as central maxima, and A is called as width of the slit. Wavelength must be known. By using all those things, A can be found out. Look at the value of A. The value of A is very small. 1 millimeter itself is very small. 0.001 millimeter means, you just imagine how the width of the slit should be. The width of the slit is too narrow. That's why it is able to create this kind of diffraction pattern on the screen. Okay. So very simple problem, may be asked in 2 mark also. Practice this kind of problem. Okay.